All right, welcome to Miss Angela's math class, and this video is 10-5 on trigonometry there. We're going to be finding the area of regular polygons using the formula 1/2 apothem times perimeter. Unlike regular hexagons where we can use 30, 60, 90 triangles and special right triangles, for these ones today, we are going to need to use trigonometry to find our missing piece of this. So we need one of three things to go ahead and find the area of these. Either the apothem, which is perpendicular from a side to the center, and it also bisects our side, so that's important to remember. Or the radius, which goes from one of the vertices to the center. Or I just need a side length, that S there. When I'm doing these calculations, though, I'm going to be dealing with this triangle right in here. And therefore, I'm going to be dealing with half of the side length for the most part. So our first thing to do is to figure out what we have. So in this case, I'm given a side length of 6. Meaning that each of these are 3. Right? So I can easily find the perimeter part of this. This is a pentagon. So my perimeter is number of sides 5 times the side length 6. The perimeter is 30. And let's remember to keep our units centimeters. So what I need to solve for is the apothem. The apothem, right here, I'm going to go ahead and pop out this triangle and see if I can solve this. So let's go ahead and pull out this blue triangle and see if I can solve for this A, and I know this side is 3. In order to use trig, I need to find that angle up top there. I can use the idea of central angles to go ahead and find this. So my first step is find the central angle. In this case, right, we have a pentagon, and for any regular polygon, I can go ahead and figure out the central angle by taking 360, which is the sum of all central angles, because it goes all the way around in the circle, divided by the number of sides. So in this case, we'll take 360, divide it by 5, and I get 72 degrees. Right? So what that is this entire angle right here. The central angle connects to adjacent radii. Okay, so that's 72 degrees. So in order to find the angle that I'm looking for, this angle right here, I need to take that 72 and cut it in half because my apothem bisects the central angle. So half of 72. So we're going to cut central angle in half. Half of 72 is 36. So that's 36 degrees right there. The next thing I'm going to do is use trig to find A. So if I'm looking at this right here, remember using trig. There is my hypotenuse across from the right angle. And across from the angle we have, there's my opposite. And the nice thing about this, the apothem is always the adjacent when I'm pulling these out. So this A, my big A. So I have O. I'm looking for A. I'm going to be using tangent up here. I'm going to give myself a little bit more room. So always write these out. Right? We have tangent of 36 equals opposite over my adjacent, or the opposite in this case. And when what I'm solving for is on the bottom, I can switch places with them. The opposite is 3 divided by tangent 36. And I get 4.1. So there's my opossum right here. So now I can calculate the area using 1/2 opossum times perimeter. I solve for the opossum, 4.1. My perimeter, as calculated up above, is 30. So plug each of those in. I get the area equals 1/2 times 4.1 times 30. And I get an area of 61.5. And in this case, we're talking about centimeters. Next, I'm going to find the area of a regular octagon when I'm given only the radius. All right, so when we're given only the radius, this one turns out to be the most challenging one because I need to use trig twice. One to solve for the opossum and one to solve for the half of a side. All right, so I need to find both of these. So we're going to go through the same steps, but let's go ahead and label our radius in there. From the center to the side, this radius is 8. And let's go ahead and mark the triangle I need to solve for. So this right triangle right here, where I need to find this x to that little a, right? Remember when we're solving for that x, it's just going to give us half of a side. So I'm going to need to double it to find the whole side. So let's go ahead and take this out, label it, and go ahead and start using our trigonometry. All right, so again, step 1. Find the measure of the central angle. 360 divided by the number of sides, which is 8. So in this case, 360 divided by 8 is 45. So that's this whole angle right here. So I still need to take that and then divide it by 2 to find this little angle right here. So this angle right here is half of 45, or 22.5 degrees. So let's label this 8. Then let's go through and solve for half the side and the opposite. So the first thing, again, I'm going to do when I'm using trig, let's go ahead and label our hypotenuse, the opposite, and then the adjacent. So I'm going to have to use trig twice to solve this. The first one, let's solve for this x. So I have h. I'm looking for o. So we have sine of 22.5 equals x over 8. And then to undo division on this side, I'm going to multiply. So x equals 8 times sine 22.5. and we get x equals 3.1. It's important to remember that that 3.1 is only half of our side. So our full side is 3.1 plus 3.1, or 6.2. Next, let's go ahead and solve for the a over here. We have a and h, so that's going to be cosine 22.5 equals a over b. And again, I'm going to multiply. So a equals 8 times cosine 22.5 or a equals 7.4. So 7.4, that apothem right there. So now I have everything I need to go ahead and find the area. The area equals 1/2 apothem times perimeter. A equals 7.4. And then my perimeter, we have 8 sides, and each side is 6.2 inches long. So 8 times 6.2. Our perimeter is 49.6. So again, plug that in there, and we can find the area. 1/2, 7.4 times 49.6. And I get an area of 183.52 inches squared. All right, so the next problem, we want to find the area of a regular decagon. And we're given the apothem. So let's go ahead and draw our triangle in there again. So we have our center. We're given this apothem is 14. Let's finish drawing in our right triangle that we need. And what I want to solve for in this case, so I can use 1/2 apothem times perimeter, is half the side length. So I want to solve for this x right here. So let's go ahead and pop this triangle out and see which trigonometry I can use. So first, find this central angle. Central angle, 360 divided by 10. So this whole thing is 36. And then we're going to take 36 divided by 2. And this is 18 degrees. I have this is 14, and I want to solve for that x. Let's label our triangle. H, O, and A. I'm looking for O. I have A. So this is a tangent problem. Tangent of 18 equals x over 14. X equals 14 times tangent of 18. So x equals 4.5. So this is 4.5, and this is 4.5. So the entire side is 9. And the perimeter, therefore, is 10 times 9. The perimeter is 90. So now I have everything I need to go go forward and use 1/2 apothem times perimeter. So half of 14 is 7. 7 times 90 is 630 centimeters. And I do understand there's rounding involved. So if you're in the ballpark for those, depending on how you round your trig functions, you will still get credit on the exam. All right, the last one. An equilateral triangle. Remember, we have several different ways to find the area of triangles. We have 1/2 base times height. We have the square root of 3/4 times the side length squared for all equilateral triangles. And then the last one we have is what we'll use for this one. Area equals 1/2 apothem times perimeter. We can use any of those to find the area of this triangle. So let's first label what we have and see if I can go through and solve it. So I have a radius of 6, and then there's my apothem, and there's half of a side. So again, let's find our central angle. We take 360, divide by 3, and we get 120 degrees. And then divide that by 2. This is 60. Hey, wait, I have a special right triangle. That's a 30, 60, 90 triangle. And remember our 30, 60, 90 triangles. We have that special pattern. We have the short leg is x, the hypotenuse is twice the short leg, and the long leg is the short leg times the square root of 3. So what I'm given here is this one. So that's 6. So x must be 3. So there's my apothem. And then half of the side is going to be 3√3. So a side length here is 3√3 plus 3√3, which is 6√3. And I have an apothem of 3. So now I can go ahead and find the area. So let's take this aside over here. Area equals 1/2 apothem times perimeter. My apothem is 3. The perimeter, since there's 3 sides, is 3 times 6√3, or 18 square root 3. And now I'm just going to go ahead and plug those in and find the area. And in simplest radical form, half of 18 is 9. 9 times 3 is 27√3. And let's not forget our units, centimeters squared. And the decimal equivalent, 27 times 3, we get 46.8 centimeters squared. So that's how we can find the area of any regular polygon using the 1/2 apothem times perimeter, and our knowledge of solving right triangles using SOHCAHTOA or special right triangles. Thank you for watching this video. Please come back soon.